I'm going to talk to you today about optimizing energy, and we're focused on the water and wastewater industry. So I'm just kind of curious, how many water and wastewater utilities out there? Anybody? A couple raising their hand? All right, that's good. How many pi users out there? Wow, that's great. How many people can spell pi? Okay, there's some people that didn't raise their hand, so we're going to go a little bit lower in this presentation. So I want to introduce a couple of my cohorts. I'm Jeff Neemann. I come from a process background, lead the technology group, and so we're looking at it, some of the analytics from a treatment standpoint. Been with Black & Veatch 17 years in the water and wastewater industry. I have 2 kids, 9 and 14. Yeah, I know those are unique names, but we like them like that, so. All right, the jokes don't get any better. Come on, remember, this is afternoon. Jacques Brados is here. He's going to be up talking in a moment. 25 years in the computing, self-proclaimed nerd, an original member of the Beatles. So Kevin Bogart here is one of our integration people and was the inspiration for the movies The Terminator. So just some little known facts about Kevin. So those that don't know about Black & Veatch, we just hit our 100-year foundation this year. So large engineering company, focus a lot really from a power, water, telecommunications, federal, and other industries. And so we're getting into the smart integrated infrastructure aspects. So I'm going to talk a little bit about some of that today. Offices around the world, 7,000 active projects. And really what I want to talk about today is how maybe from an engineering perspective, we're transitioning from delivering a project, you know us as the people that go build the infrastructure for you, to transitioning to how can we help you support during the operations aspects. And that's a lot of what we're going to talk about today from that standpoint and some of the solutions that we're working on relatively. So why analytics? It's a little bit like preaching to the choir. Probably you're here because you're thinking about that. But when I start talking about this in the water and wastewater industry context, they're kind of behind the curve than I think a lot of some of the industries. And not meant to anybody who raised their hand, you're here, you're probably ahead of the curve. But in general, as I've gone around over the past 2 or 3 years talking with them, they're a little bit behind that. So each year we do what we call a water industry survey, and we ask a lot of different questions. And I wanted to highlight a couple things that I think relate to why we're here and why we're talking about analytics. And one of those is the significant sustainability issues. Maintaining or expanding asset life is one of the top things out there. And some of the things we're looking at as we talk to utilities, we see analytics playing a role in how that can happen from an analytics standpoint. Long-term financial viability, of course, is important. Customer water weights, other things that are important. But it's that asset-centric aspects and things that we're really focused on relative to what we're doing. Another thing I think from a water and wastewater industry, when we ask about energy efficiency things, the top thing, reduce losses or other efficiencies, basically taking and replacing old aging equipment is one of the top ones. Using distribution modeling and tools better, so that's a technology thing. But the number three is implement software and or data analytics around that aspect. So again, we see these as we go out and survey the water and wastewater industry as things driving us more toward that aspect and where we're heading. So what's the driving thing? I like to give this example a little bit. Anybody have a cell phone that looked like that? Few people around here. What changed? The cost has gone way down, size has gone way down, availability and function's going way up, right? And so what's going to hopefully see, and you've already seen it in some of the other industries, but the water and wastewater are starting to see it finally is, oops, if I go forward instead of back. There we go. On the data side, as the cost of storage and cost of sensors go way down, especially for water quality and other things, access and computing power are going to go way up. We can hopefully help water and wastewater utilities transform how they make better decisions. So at Black & Veatch, we call that smart integrated infrastructure. Now, unlike many things, it's not a one-time project. It's not just, hey, we go do one thing and we get there. It's a journey. And let me just look a little bit at this figure. It kind of, as you take data to information to knowledge and wisdom, and you move up that curve and potentially have higher impact, that's really what we're talking about. So how do you get from a smart network where you may maybe have connectivity and you start to bring the data together to smart information where you have really aggregation analysis, you're maybe focused on single-use aspects, looking at one certain part of the facility. Smart utilities, maybe where we're starting getting systems working together, and then all the way to the top to the smart integrated infrastructure. That's maybe in some people's terms or vernacular nowadays like a smart city concept. So this is a journey, and I'm not going to ask people to raise their hands and maybe think where they are on this curve, but over the past couple of years, as we've been going and talking to water utilities, I think in general they're pretty low on that curve. And so relative to electric industries and other industries, they're kind of down there. They have lots of data that's coming out of the ears and they haven't done much with it. So what we want to talk about today is a solution we're bringing to that water and wastewater industry that we call integrated data management and analytics, that is really trying to address that. So we see this as the base, as the first good step to a water and wastewater utility that maybe hasn't really started that path, hasn't started to leverage things. And that's what I want to talk about today a little bit is that integrated data management analytics. And it's about taking that data and bridging the gap between data and value. And how can we turn and do something with that data that's actually productive from a standpoint in the water and wastewater side? So one of the number one things really as we go out and start talking to water and wastewater utilities is the data silos are prevalent. So very much in the water and wastewater industry, we're a SCADA-centric aspect. Lots of people really think about, when you start talking about data, they go straight to SCADA. But in reality, there's a lot of other things and a lot of other silos. Laboratory information, GIS, plant design information in terms of, or O&M information, customers, water meter, asset management, power monitoring. There's lots of different silos. And as you go talk to them, it's very common to say, well, if I want to do something, I go talk to Jim to get this data, I go talk to Sally to get this data, and somebody else to get that other part. And we see that as that fundamental first bridge. So how can we do something about that? Really what it comes is to bridging that gap, and it's finding my generic term of a data hub, but in reality we've established a partnership with OSIsoft to help be that connector, to be that first part that can bring some of these systems together. And I think if you've been through some of the sessions today, you're going to get that over and over in terms of the data, the people, and ultimately transforming how people can do their operations. And so that's really what we're focused on from a Black & Veatch perspective. And so what we're trying to do in the water and wastewater industry is develop a partnered offering where we have OSIsoft combined with Black & Veatch analytics, ultimately to hopefully inform decisions. So I'm not going to spend a lot of time on the OSI side because you have a lot of background on that piece, but want to talk a little bit about, so what are the analytics and the things that Black & Veatch is working on? So we call our platform Asset 360. So it's about big data. It's about bringing operational intelligence, the real-time information and things that are happening now, and combining it with adaptive planning and the future-looking aspects. And when we bring those two views together, that's really the heart of what we're calling Asset 360. So based on OSI in the background, single point of truth, trying to bring scalability to this in terms of bringing this to all water utilities. So those maybe coming from other industries don't realize sometimes I'm trying to remember the number, 25,000 or whatever water utilities. There's a lot of small utilities that we have the potential to bring tools to if we can be scalable. Collaborative problem solving. So that's maybe one aspect. Ultimately, at the end of the day, we're not trying to just develop software or applications. We're also trying to connect them to expertise that we have from an engineering perspective. And we'll talk a little bit about that in a little bit. So we've been doing this for about 20 years in the power industry. And so this is a shot of some of our monitoring and diagnostic center. You can see in some of the pictures up in the top. So we've been doing this in that industry, and now we're trying to bring this into the water and wastewater industry in terms of how we can take and leverage some of the things we're doing and bring some of these analytics combined with that expertise to ultimately provide value to water and wastewater utilities. Now we're doing this in a bundled data management and analytics model. So ultimately you do have that equipment and instrumentation, all that Internet of Things out there, have some aspect of a network to get that back. And then you can see the PI system there as that data integration, storage management, and visualization layer. So bringing that together. And then Black & Veatch going on top of that layer and doing some analytics around monitoring diagnostics, scorecards, other issues in terms of finding issues before they become problems in that aspect. And so some of the things that we're maybe doing a little bit different from a water and wastewater perspective is we're bringing that whole bundle together as a software as a service. So we're able to provide the hardware, we're able to provide all the configuration services, set everything up, and do it as a pay-as-you-go aspect in terms of that. So different approach from a water and wastewater industry, and seeing how we can maybe get this aspect in, get the analytics, get the data aggregation into water and wastewater utilities, and build the value over time. So now I've kind of set the case of the what and the why and the how. Jacques now going to come up and talk about a couple examples about how we're starting to do these types of things for water and wastewater utilities.
Thank you very Much, Jeff. I appreciate that. I also have a teenage daughter. She's 16. When she was born, we named her, "You're 18, it's time to move out." That's been kind of challenging issues growing up, but she's starting to get the message. Jeff, thank you very much, and it's great to get the nice preaching to the choir. It's time to do some real work. Some of the stuff that we've done at Black & Veatch, energy focused, again, on the water side, distribution energy selection, what's the best water source. A district metered area has a well site and a pumping station with a reservoir. For those of you not in water, the district metered area is just basically a big area. The particular one we're talking about, it's got about 6,000 houses and industrial areas. They're drinking about 60 million gallons of water a day in that particular area. With these two different energy sources, two different water sources, what is the most electrically energy efficient to provide water to that? To answer that question, we need flow rate and pressure out of our SCADA system. We need some system design curves, pump curves. We also need that electric company information about what is our billing rate, how much are we charging for all the energy that we're using. I also did want to point out here that I didn't have electric energy from the pump sources. I've only got the mechanical energy. And we were able to get them some pretty good answers with just that little bit amount of information. We are obviously bringing this stuff into Pi. Active or AF is a wonderful thing. Templates are wonderful things. And the ability to stack templates on top of templates is a wonderful thing. So we obviously want to calculate what is our electrical cost per million gallons. I got to take my gallons divided by a million, obviously, and then my electrical power cost. Already you're seeing two things factored there, but electrical power cost is interesting because I'm getting my data about every 15 minutes. I have to, in that 15 minutes, figure out which rate structure am I in. Not only that, what time am I inside of that rate structure? So each one of those calculations are inside of each other, and Pi does it beautifully and quickly, and we're very happy with that. This is one of the Black & Veatch visualizations about this particular area. You're seeing a well site. In this month of time, we did about 34 million gallons, 34.7 million gallons in that time frame. The pump station did about 32 million gallons, so they're basically equal. Kind of jump into the highlighted area, we did $53 per million gallons in energy, $54 per million gallons in energy from these two different sources. At first blush, it looks like we've got the operational flexibility to choose either one of our water sources, right? But let's dig a little bit deeper because we like analytics. What we see is when we do our millions of gallons per 1,000 kilowatts or megawatt hours of energy, the pump station was more electrically efficient, about 1.4 million gallons per megawatt hour versus 1.1 million gallons per megawatt hour. So why does the cost look the same? And as we dug a little deeper, sure enough, one of them is in time of use, and one of them is in a constant throughout the system. So just changing the billing rate is going to save us 20% from this one water source. That's going to be about 10% across this one area. So it's a electrical savings. We didn't change the way we operated. We didn't change anything we do. We just make a phone call. Okay, great. That's yesterday. What are you going to do for us tomorrow? Well, what we're seeing is that we're different efficiencies at different flow rates. And why is the pump station more energy efficient than the well site? The answer already is that the well site is a single 300 horsepower pump that has to change its speed to match the demands for all the water that's flowing. The pump station is a combination of 5 pumps. So there's different combinations, and 2 smaller pumps at the pump station are more electrically efficient at lower flow rates. So let's look at the efficiency at different flow rates. We'll also need to consider electrical demand charges. I may not want to start that 300 horsepower pump even though it's more efficient at the higher flow rates. Let's work into our demand predictions. Let's look into the water production costs. The cost of water in the reservoir is coming out of a treatment plant that's got chlorine and all other kinds of great treatment chemicals. Let's take those costs into effect as opposed to what's coming out of the ground that's relatively inexpensive to treat. However, it does have an environmental impact. We want to be good stewards of our water and not pump everything out of the ground. Oh, by the way, there's actually 6 water sources to actually balance across in this equation. So doing this analysis, we're going to actually come up with different operational things. Haven't solved that yet. We're going to submit our paper, and hopefully we'll get selected, and you're going to hear that next year. The next example that we did out in the real world is a drinking water station. Different customers got 3 250 horsepower pumps. Again, these kind of start in a league lag to be able to provide water to this area. The operator reports that 3 pumps are needed more often to meet flow requirements, which seems unusual for those guys, right? Great, we're going to happy to come in and look at that. Again, we need pump speed, flow rate that's coming out of the SCADA system, pump design curves. Notice again, not on this list, electrical is not there. So you guys that are designing power systems and PI systems and water systems, it's great you're bringing in the suction pressure and the discharge pressure and the speed. Please bring in the volts and the amps and the kilowatts coming out of the VFDs. It's going to make our lives so much easier. It's worthwhile saying that the pump is 7 years old. When you look at the first blush of the data, you're seeing 7 years of plot across here, our flow in million gallons a day across the bottom, the amount of energy or the total head to discharge. At first blush, it looks normal. The top squiggly line that you're seeing there is 100% pump speed. The bottom line is 67% pump speed. So really, no pump ever run below 70%. It looks normal. However, just looking at the SCADA data, when you throw on the pump curves, it turns out that there is a minimum flow requirement of 2,000 gallons per minute. And sure enough, you can see a pretty significant amount of piece of data that they're spending time down there. In a smaller room, I would ask what happens when you run a pump at high speed in water with low flow rates. The answer is you get recirculation cavitation. These are both pumps, pumps 1 and pumps 3 that came out of that station. Pump 1 that's on the right has completely eroded away. Those are supposed to look identical. The one on the left has got significantly less wear. So what happens for the water people, what happens is you've got a pump that's basically churning water. So you're turning a blender basically inside of a pump cavity, and that water is literally eroding away that impeller. The one on the left, not nearly as eroded. The reason for that is there's lead lag and off, so you can tell it which pump I want to run at which time. In 7 years, they never really changed it. So at those low flow rates, pump 1 runs all the time at the higher rates, 2 and then 3, so pump 1 got the most amount of wear anyway. What's the energy impact along with that? We estimated there's about $100,000 worth of lost energy savings spinning a pump that has no impeller for about the last year and a half. Again, this was extremely challenging to notice because electrical energy is not in SCADA. And of course, the design limits were not designed into the SCADA system. For us to solve this, we ended up using the affinity laws so that power is proportional to the cube root of, or the cube of speed. So again, please bring that VFD data into your PI system. It's going to help us with a lot. So those are 2 examples that we've solved. Looking forward to sharing many, many more. I want to talk a little bit about connected services. Jeff had mentioned it before that we've got lots of PI customers that are out there. We've got a large server sitting in Kansas City, which is Black & Veatch headquarters. We are bringing all of that data. Connected services, we've been talking with PI and OSIsoft about that, and we're actually pretty excited about it. So how are we going to end up doing that? The customer on site database can obviously publish information into the cloud. It is a publish and subscribe, so they get to decide what it is that they're going to publish up to the cloud. The Black & Veatch PI server then subscribes to that customer data so that we can bring it in. Our PI server is going to do that analytics on it. That's very important for us. And then once we've done that analytics, be able to publish that back out there for that analytical result. The benefits for that, of course, is the customer data is secure. Black & Veatch has got great security, and we've been keeping the power companies happy for 20 plus years with our security. It is challenging to do that. There's lots of stuff to be NERC SIP compliant, which is on the electrical power side, for the water side. So their data is secure, our data is secure, and our intellectual property is secure. In first blush, we don't want to do that PI analytics and make that available to the people. We want to do that analytics locally to us so that we do that dollars per million gallons, just for example, which is an easy calculation. I'm going to do that at the PI server in Kansas City and then just publish the result out to them so that they can have that. And of course, when they bring it out to the cloud into theirs, they've got their asset framework that they can certainly do their calculations on and go from there, and that's fabulous. That offer also opens up the software as a service purchasing option. So in the whole thought of Black and Veatch, of we come in, we do a project, and we leave, now it's ongoing source of revenue, ongoing support for providing analytics. And if you don't find value in that, then please call us, because we will help you find value in that. But it's a whole new purchasing option for those guys. And the multiple customer sets are completely separate. So customer A only sees their data. Of course, Black and Veatch has got all their data integrated. So cloud services maintains the security and adds benefits that we don't have today. We have 2 customers that we're currently talking about. Turns out the biggest challenge for us installing a PI system and doing data integration for them is, of course, the lawyers, getting the lawyers out of the way. We've been talking with these guys since November, and we were hoping to be having a lot more with it, but we're just talking about what we're planning on doing. With that said, we've got a Black and Veatch customer. Black and Veatch is providing the PI server to them. We're going to be connecting to their water meter usage database. They're using Elster as their front end. We're going to be connecting to their GIS maps, and we're going to be connecting to their Wonderware historian, which has got all their water supply zone. So they're having a challenge with how much water are they losing on a monthly basis. They've got these 3 silos of data. They can't get them to connect. We're more than happy to do that. The other fabulous thing that's going to be able to do that for us, help them, is all the levels of the organization are going to have access to that information. The SCADA system is all locked up in a system that they can't get to. All of the meter reading data is all locked up into a system that only those people can get to. And the GIS, of course, is a little more open, but what a wonderful thing to be able to share that information through all these different organizations so that they can start seeing it through either our visualizations or on their local PI server to do their own analytics if they should choose to do so. The second test case we're working on with is a wastewater treatment plant. This is just kind of general plant optimization. It's a smaller customer. They have very scarce IT resources. They were very happy to hear that Black and Veatch is going to provide the PI server. We're going to go on their site. We're going to install it. They're going to provide us an IP address and work with them and get some power. But besides that, it really shouldn't impact them very much. They're using Prophecy Historian, which is an iFix or a General Electric product. And again, it's really just seeing the plant optimization. The general manager of the plant, and for that matter, the city asset management people want to be able to see, what is my plant doing? What has it done? They don't want to wait for the SCADA system people to be able to email out, this is what happened last night. So another great win. We're going to integrate. We're going to show them some of those basic business calculations that they can't see. We're going to provide that to all levels of the business. And really, Black and Veatch is also going to be providing those monitoring services for them. With that said, thank you very much for your time. I'm more than happy. There's about 6 minutes left. Happy to answer any questions that you might have about anything. Got one question? Go ahead.
Yeah, I'm Perry Holland from Denver, Colorado, work at Metro Wastewater Reclamation District. And one of the questions I have is process optimization. We talk a lot about energy optimization, water optimization. Does your product seek to do any kind of biological process optimization or chemical optimization that you see a lot in wastewater?
The answer is absolutely yes. We submitted paper on energy optimization, so that's what we stuck to. We are doing analytics probably in about 15 different areas as far as process optimization, chemical usage. Certainly on the wastewater side, we've got very good algorithms that are predicting those biological processes. DO control, flow control, airflow control for based on dissolved oxygen. Jeff's really more of an expert on the wastewater side. I'm more of the distribution stuff. But yes, we're doing a lot of that stuff on the plant drinking water side, chemical injections, most injection rates. People in general over-treat their treatment plants. The treatment plant operators are paranoid about violating, don't want to get anywhere close to that. And to solve that, they basically over-treat the water and use too much chemicals. So trying to optimize that with that history and that future prediction to be able to tell them, you know what, you can dial down on those chemicals and save a little bit of money.
From a process standpoint, we're just starting a pilot with Winston-Salem, North Carolina, one around DO control. looking at their aeration basins and how to balance DO at their different feeds. And then we're also, they have two wastewater plants with a pump station between them. So we're also looking at real-time cost and energy use across those two to help them decide how much to transfer between the two plants. But that's the extent that we're going to. You're right. We're focused on some of those process aspects. That's kind of my background. So we're working on developing some things in that.
I saw a hand in the middle.
Do you guys generate your own algorithms?
Do we generate our own algorithms? Yes, we do. Yes, we do. And that's what we're very grateful with the power system guys. They've been doing that for 20 years. The efficiency of a pump or a pumping system is pretty much straightforward from place to place. You know, filter density and chemical usage inside of a treatment plant, yeah, the water guys are working on that. Black & Veatch has got some great PhD level chemists that are working on those algorithms.
We see it a combination of that aspect of math and people in terms of out there consulting with the water and wastewater industries. So yeah, we'll have analytic aspects, but we also have the experts that may look at your data periodically on a quarterly basis or as needed. Hey, we're having a problem. What's going on? We could go look at that data too.
I saw the one back in the back.
Yes, Charles Dobbins from American Municipal Power. I noticed, heard you say that you were able to show your customers their own information. Question's kind of twofold. Are you using Pi CoreSight for that? And if so, how are you getting that so that each member or each customer can see just their own data?
All right, so thank you very much. We're not using CoreSight right now. We're using our own visualizations that Black & Veatch has developed, again, out of the power side. And it's user-based permissions. So part of our offer is that, you know, we don't really want to get into all the different permissions. You provide us a list of usernames and passwords, and we're more than happy to load that into your system. And then those people have access to, you know, we start with believing that more information to everybody is more powerful. If you want to limit so that only these people can see this and these people can see that, yes, you can go do that. We do like CoreSight. We are experimenting and using it with CoreSight. We certainly encourage them locally on their local Pi server to use CoreSight, and we help set them up for that so they can go do that. But the analytics that Black & Veatch is doing, usually we're doing that with our own visualizations and pumping the results down to Asset Framework locally so they can visualize it on their own CoreSight if they wanted to.
Hi, I'm Tony from Tesla Forecasting. We do energy forecasting, and I was just curious with Pi and the ability now to read in future dates and times, do you guys currently do any work with combining forecasting power usage as well as forecasting demand for water usage?
So we're working on that. We're working on that.
What we've been looking at is we haven't been using some of the Pi tools. We have some of our own math capabilities. So one of the water examples of demand for a water system is using AMI data and using that aspect. Right now we've been looking at combinations of using our own math, but then aspects of how we can do some of those calculations in Asset Framework and some of the things within the Pi tools. So it's kind of a to be determined in terms of that aspect. And it gets back to the question of do we have our own algorithms? Well, some of those are our own, if you will. Some of them will be baked into the system within Pi.
Right. Any other questions in the front row?
Yeah, Brian Owen, California citizen. We're shortage of water here. Do you see any application to help us with our water shortage? Any ideas for that?
The answer is absolutely, absolutely, right? It is a relatively new 3-year product, you know, for Black & Veatch, and we are optimistic that as new customers come in, that really we can do analysis region-wide, county-wide, statewide. Just because you're a utility and you're a utility and I don't let you see your data, I can see your data. And our guys are wanting to be able to use some of that, do some of that analysis to make some recommendations about how to deal with droughts that are coming in California and really nationwide.
Yeah, I see twofold aspects of that. One, the individual utility that we can work with and obviously connect and do analytics for. But two, can we look at somewhat of a virtual regional utility aspects? Can we look at community use across a whole community? Because one of the issues with water that's different in the grid is around LA, you know, how many different water systems do you have? Here in San Francisco, you have PUC, but you go around the whole Bay Area, there's lots of different water systems. So how could we use something like Pi to connect the data and so that everybody could see what use is across a whole community, not just at an individual utility-wide, if you will. So, because you got eventually a state, right, that has to reduce by 25%. So how could we set up an anonymous set of data so people could see how you're doing as a whole community or as a whole state? That seems like a likely possibility.
So with that said, the big clock's flashing. He's going to get the hook to pull us off. If you got some more questions, feel free to come over and talk to us.
Again, really powerful story about how you're leveraging the Pi infrastructure to deliver analytics and real value. So thank you again for the team from Black & Veatch. Please, round of applause.